Greetings. Good day. How are you guys doing today? Welcome to. This is a physics lesson. Yeah. This is a physics lesson. Welcome. Lesson number 13. Lesson number 13. It's been a long time, right? Now today we are looking at work and power, and it's gonna be hopefully a short video because there isn't much to explain. All we want to do is that by the end of this lesson, we should be able to define the term work, define the term power, carry out calculations to determine work done, and carry out calculations to determine power that is being used. So you will find that in terms of the notes and the explanation, it's material that was covered and that I explained when we were in grade 9. I explained this stuff. I'm sure it was explained to you. Whichever school you were at, they explained to you what work is and how you calculate work. So what I'm mostly going to be concerned with is you guys doing the calculations, these calculations which are at the end of the document. That's what I'll mostly be concerned with. So let me just go over these two concepts of what is work and what is power. So you'll find that the first thing that I put in those notes was what is work and how there is a difference between our understanding of work from everyday life as compared to what work is in physics terms. In everyday life, we just assume that anything that makes you tired is basically work, right? So we'll find that in everyday life, we'll just think that, okay, I did this for a long time. I was standing here carrying this big bag before I was allowed to get into the hostel. So I did a lot of work and now I am tired. But effectively, you will find that you haven't actually, in those situations, you wouldn't actually have done any work. So we are mostly concerned with what work is in physics terms. Okay, so we have here definitions, explanations. Say work is done when a force is applied on a body and moves it a certain distance, right? So this is the definition for work, right? Work is said to be done when a force F acts on the body and point of application of the force is displaced. Point of application referring to wherever you are applying the force. If you are pushing a car, or you are pushing whatever you are pushing, you are carrying whatever you are carrying, you are doing whatever it is you are doing, if you apply the force and the point of application, the object on which you are applying this force, moves in a specific direction, then work is done, right? And you find that here we say work is equals to force times displacement. Force times displacement. For you guys, I was saying to the grade 9s, they will have to ask you what displacement is. And I hope you remember that we said displacement, right, refers to a situation where you have moved a certain distance in relation to an origin point. So how far away are you from point A, your origin point? So I said it doesn't matter if you are standing at the grade 10 classroom and you move all the way to the grade 9B classroom, right? And then you walk back to the grade 10 classroom. And I asked, what is your displacement? Your displacement there is 0 because you are still at your origin point. Yes, you have moved a distance of maybe 20, 40 meters, but in terms of displacement, you have actually not moved at all in relation to displacement. So that will give you an idea of positive work and negative work. So if you actually carry a bag of cement from your classroom, your grade 10 classroom, and you carry it all the way either to the dining hall, and then you carry it back because here there is an issue of direction, because you will find that work here is an issue of direction. I don't know why we're saying it's a scalar quantity, right? But we're going to have an issue of magnitude, and we're going to have an issue of direction in which that quantity is moved. Because if you move forward and then you move backwards, then you can actually have positive and negative work being done. But for now, let's just focus on the positive work. So, NB, unless the force applied makes the body move, then no work is done, right? No work is done unless the force applied. So you will find here that Mrs. whoever is pushing the wall for whatever reason that she's pushing the wall. She's pushing the wall, but the wall ain't moving. It's not moving, so no work is done. No work is done. She's pushing the wall. So if you're pushing a wall or you are moving an object which is extremely, it's almost stuck to the same place, it means that no work is being done. Then here we have an image of a cricketer, right, uses his bat to hit the ball. Right, I hope you've ever watched something called cricket. Wonderful sport, right? So when a ball is thrown to the batsman, he's going to hit the ball, and force is applied on the ball, and it moves. It is displaced, so work is done on the ball by the batsman. Work is done on the ball by the batsman. And you will see here the conditions that are required for work to either be said to have been done or not to have been done. So you can just pause the image for a bit and take in situations, the explanation as to when work is done and when work is not done. Right, so just to round off, we know that the unit for work is the joule. The unit for work is the joule, which is the same as the Newton meter. So when you're calculating work done, you say the distance is in, let me see if I have something here. Right, so the distance is in newtons, the distance is in meters, and the force is in newtons. So you say newtons multiplied by meters, because you're saying force multiplied by distance. So what you're going to have is, don't worry about the positive and the negative work. But since it's on the screen, you can just look at it yourself. Right, here, SI unit of work. The SI unit of work, where you find that force is in newtons and displacement, distance, is in meters. Therefore, if you say work is going to be equal to newtons multiplied by meters, that gives you the Newton meter. And that Newton meter is equivalent to 1 joule. Right, it's just, a bit of information to tell you where the name came from. Very soon, I'm sure, Tuna, you discover something, or Rita, you discover something, and then when we want to say how much work was done, you say 1 Rita was done, or 1 Jane, or 1 Sikopo. I don't know. You guys, when you discover something great in science, you have the privilege of either naming it after yourself or naming it after your dog or your cat or something that you like, right? So now let's move on to power. Let's move on to power. Power refers to the amount of work done in a given amount of time, right? Work done per second. That's now rate, R-A-T-E, the rate at which work is done. Right, it's also given here as refers to the rate at which energy is transferred from one form to another. But it's basically the rate at which work is done. So if you do 5 kilojoules of work, and you do those 5 kilojoules of work in 50 seconds, we are going to have you divide that for you to find the amount of power that was effectively used. And then that answer, when you then say, is then in watts. The unit for power is watts. Remember, the unit for work is Newton meters, right? That's now Newton meters, Nm. When you now want to find power, it's now Nm over S, joules per second. It's now Newton meters divided by seconds. And Newton meters divided by seconds is the same as writing the letter W. The unit for power is the letter W. So that's the formula for power. Power is equals to work done over time. Work done over time. Then, yeah, it's a very simple concept. You can read up more on it wherever it is you can find information. Then the questions. Determine the work done. 50 newtons was used to pull a box for a distance of 800 centimeters. Determine the work done. I think the only thing that I would add before I finish this lesson is that we should always know what the SI unit or what the base unit we're supposed to be using is. We know that work done is calculated in Newton meters, so you have to say 50 newtons multiplied by, change these 800 centimeters into meters. Please, don't say 50 times 800 and then you end up getting some 40,000 or something funny like that. And then you say the 40,000 joules of work was done, because you just didn't have the presence of mind to calculate or to change your centimeters to meters. So if you are given work and you are given it in kgs, change your kgs to newtons, right? If you're given a mass, change it. If you're given it in kilometers, change it back to meters. If you're given something in hours, change it back to seconds. Please, just follow the base units, okay? So guys, thank you very much. That's all I have for you. We'll obviously do those questions together in the lesson. So thank you very much for watching the video. This is your teacher, Marshall A.C. Candiado.